Alright guys, so this paper we did today, it was on a subject known as linear programming. Pretty much on this paper, we applied everything that we've learned this year to be able to solve these problems. These are very long problems. You need to be able to read and write down inequalities and equations. You have to see the whole picture. So it's pretty difficult, alright? I'm going to go ahead and work through the hardest one on this page, which is number 2. I think I already did it in class, but just to do it one more time, I'm going to do that. I'm also going to fill out the backside after I read through it and write down my equations and my inequalities, okay? Again, just before so we can learn a little bit before I get too far into this, my inequalities are also known as my constraints. It's what limits I have on my on the problem, and then also the equation that's going to be at the end. That's going to be my sorry, I'm drawing a blank. It's right here. Optimizing equation. Okay. So let's go ahead and start on number 2. I'm going to zoom in a little bit so y'all can see it better. Oop, it's a little too far. All right, that looks fine. Okay, so number 2, it says a company makes 2 models of light fixtures. There's model A, there's model B. Now, generally speaking, I would just use 2 variables A and B for this, but I'm going to use X and Y just for the sake of the back side of this paper. X and Y, each of which must be assembled and packed. So we're doing 2 things. We're assembling and we're packing. The time required to assemble model A, so it takes 12 minutes to assemble model A, and it takes 18 minutes to assemble model B. It takes 2 minutes, so remember, we're talking about assembling, and we're also talking about packing. So here's the assembling times. Now it takes 2 minutes to pack model A, and it takes 1 minute to pack model B. Each week, there are 240 hours available to assemble. That's hugely important. All right, so if there's 240 hours available each week to assemble, and it takes 12 minutes to assemble A, and it takes 18 minutes to assemble B, let's go ahead and write our first inequality. Now, 240 hours, let's go ahead and put that into minutes. So 240 times 60 is going to be 14,400 minutes. So 14,400 minutes. Now, that's all the time we have available to assemble, all right? So that means at the most, we can use 14,400 minutes to assemble our model A's and our model B's. So it takes 12 minutes for every model A that we're going to assemble. And then also plus, it takes 18 minutes for every model B we're going to assemble. So there are my 2 equations, or I'm sorry, there's my first inequality. That's my first constraint. My second constraint says that we're only going to have 20 hours to pack. So 20 hours to pack, again, I'm going to put it in minutes, right? This was minutes. We had to convert 240 to minutes. So just like it takes 2 minutes to package A, 1 minute to package B. So let's go ahead. 2 minutes to package A plus 1 minute to package B. So instead of writing 1B, I'm just going to write B. Oh, guys. And look, I messed up. I said this was X and this was Y. So I'm so used to calling variables by the initial letter. But look, here's a Y, 18Y, 12X, 2X, 1Y. Alright, so I messed that up, but see my mistake, alright? All I did was change all my A's and my B's to X's and Y's. And that's going to be less than or equal to, how much time do we have to pack? Well, it says we have 20 hours total to pack. 2 minutes it takes to make a model A, or pack a model A, 1 minute to pack a model B. We have 20 hours total to pack throughout the week. So if we have 20 hours to pack, how many minutes is that? Well, 20 times 60 is going to be 1,200 minutes to pack, all right? So those are my 2 constraints. That's all the constraints I can make. Now here's my equation, or my optimizing equation. If model A sells for $1.50 and model B sells for $1.70, how many of each model should be made to maximize weekly income? So model A So if model A sells for $1.50, so for every model A I make, I multiply it by $1.50. That tells me how much money I'm making on model A's. Next, for every model B I make, plus for every model B I make, I need to multiply it by $1.70, model B's. And that's going to equal my total income. Now what does it say? It says I need to maximize my weekly income, so I want to make that I right there as big as possible. Okay, so I'm going to take all this information and start filling it in on the other side of this page, okay? So again, my variables, as far as defining my variables, my X was the number of model A's, Y was the number of model B's. My constraints, let's see what they were. It was 12x plus 18y is less than or equal to 14,400. So I had 12x plus 18y less than or equal to 14,400. That's one constraint. And then my other constraint was 2x plus y is less than or equal to 1,200. So 2x plus y less than or equal to 1,200. So I'm going to go ahead and title my graph real quick. My x-axis is going, I'm going to use that and make it the number of model A's that I'm producing. And then my y-axis is going to be the number of model B's. So number of model B's that I'm producing. Alright, so there's my graph. Now before I can actually use this graph and graph these constraints on there, I need to solve for y. So let's go ahead and do my work down here. 12x plus 18y is less than or equal to 14,400. I need to subtract 12x from each side. If I'm going to graph something, I need to solve for y. I need to get that y by itself. So circle anything that has to do with y, get rid of everything outside the circle. Subtract 12x from each side. So I've got 18y less than or equal to negative 12x plus 14,400. Now I'm going to divide by 18. So I should have y is less than or equal to negative 12 divided by 18. Well, that's negative 2/3 if you wanted to reduce that fraction. Plus 14,400 divided by 18 is 800. There's one equation that's ready, or one inequality that's ready to graph. That's one constraint. And then let's go ahead and do my other one right here on this side. So I've got 2x plus y is less than or equal to 1,200. So 2x plus y is less than or equal to 1,200. So I'm going to subtract 2x from each side. Minus 2x, minus 2x. So I've got y less than or equal to negative 2x plus 1,200. Just like that. So here's another constraint ready to graph. So let's go ahead and graph this one first. I want to start at positive 1,200. That's my y-intercept, and then I'm going to go down to right 1, down to right 1, down to right 1. That's my slope right here. So down to right 1 from there, down to right 1, 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 just like that. Then I'm going to be shading. It looks like my y is smaller, so I'm going to be shading below here. I'll shade real lightly right now. Okay, and then let's go ahead and graph this one. Start at 800. Looks like I'm going down to right 3, down to right 3, down to right 3 for my slope. So down to right 3, down to right 3, down to right 3, down to right 3. So again, it looks like my y is smaller, so I'm going to be shading down here. Now the place where they all intersect, right here. I'll go ahead and shade this dark so you see what's going on. But both my shadings are intersecting in one spot, or one area. This is called the area of feasibility. Alright, so that's where my areas are intersecting at, okay? So I've got a few vertices in here. Now these are my extreme points, okay? I'm going to use these to find my maximums or my minimums. There's a vertice, and here's a vertice right here, but I'm not going to worry about that because I'm only concerned with maximums. So I've got 0, 8 as one vertice. Oops, hold on a second. So I'm writing that right down here. So I've got 0, 8 as one vertice. Another vertice is at 3, 6. And my other vertice is at 6, 0. Alright, and I'm going to go ahead, and these are my vertices. Like I said, those are my extreme points on my area of feasibility. That's what's going to give me my maximums or my minimums. And if you remember correctly, if you look over here, we're concerned with finding the we're trying to maximize our weekly income. And here was our, that was our optimizing equation. Alright, so I need to write that right over here where it says optimizing equation. So I had 1.5x plus 1.7y, that is, what was it, equals to I, right, our income. We're trying to maximize this equation right here. So let's see which one of these points maximizes that equation, because that equation tells us how much money we're going to be making, our income, okay? So if I have 0 for x, I've got 1.5 times 0x plus 1.7 times 8 for my y equals, well, 1.7 times 8. Oh man. Let's see. I'm going to, maybe I can get a calculator, or maybe I can get lucky and find a paper sitting around here that I already worked earlier today. No luck so far. Alright, here we go. Got one. Alright, so that looks like it should equal 13.6. 3.3 comma 6, so let's go ahead and do that one. 1.5 times the 3, which is the x value. And then I've got plus 1.7 times my y value. And that's going to equal 14.7. And then on my last one, I've got 6.5 times 6 plus 1.7 times 0 for my y value, and that's going to equal 9. So which one made me the most money? Well, if we're talking income, my income could be 13.6, 14.7, or 9. 14.7 is obviously bigger. So the pair that made me the most money was by making or building, looks like 3 Model A's and 6 Model B's. So to maximize weekly income, 3, now remember we were graphing hundreds, alright? So when we graphed up here, these were all by hundreds, right? So like you see here, 800, 1200, we started at 8 and 12. So these are all, the scale is by hundreds. So really 3 is we need to make 300 Model A light fixtures, and we need to make the 6 is 600 Model B light fixtures should be made, okay? So to maximize weekly income, 300 Model A light fixtures and 600 Model B light fixtures should be made. Our total money is 14.7. Remember, we're talking hundreds, so $1,470 will be the maximum income. And that's our answer, right? So by producing 300 Model A light fixtures, 600 Model B light fixtures, we're going to maximize our income at 1,470. Does that answer our question? How many of each model should be made to maximize weekly income? So again, 300 Model A's, 600 Model B's. Oops, there we go. 300 Model A's, 600 Model B's. Okay. There's a lot of stuff that goes into linear programming. So if you have any questions, definitely come into tutoring. Remember, my tutoring times are Tuesday and Thursday. Oops, Tuesday, Thursday from 4:05 to 5. Wednesday, Friday from 7:45 to 8:30. All right, and then also you can sometimes come in during six period lunch if you want to schedule that with me. Okay, just let me know in class. All right, guys, thanks for watching, and good luck. I'll see you in class later.